Arg! Oi, mateys! Here we are, starting chapter 9. This will be our last chapter of the term. Congratulations. You've made it this far. We're going to be doing 9.1 through 9.4. We're not going to do mean absolute deviation. 9.1 is all an introduction to statistics. What are statistics, you might ask? What is a statistical question? Well, that's a good question. Let's answer that. So here we go. Let's see if this works. Oh, no, that's not working. I'm going to have to hit some buttons. And all right, we're going to start thinking. So if you ask 10 classmates what their favorite color is, how many answers could you get? You could get 10. Every classmate could have a different favorite color. If you ask the same 10 classmates how many pennies are in a quarter, how many answers could you get? I mean, you could get more than one answer if your classmates were not very bright, but that is the same answer for everyone if they know pennies and quarters. There's 25 pennies in a quarter, you would only get one answer. So how are the two questions different? Well, the first question, when you're asking favorite color, that is called a statistical question. And the reason why is because you would get a variety of answers. Whereas the second question about the pennies and the quarter, that is just a factual, non-statistical question. That one, you're just getting one answer. Not a very interesting question, really, unless you need to know how many pennies are in a quarter. So, statistical questions are the kind of questions that would give you a variety of answers. Oh, hello, kitty. Okay, here's start thinking, too. What is the difference between a statistical question and a non-statistical question? Well, I just explained that. I'll do it again. Statistical questions give you a variety of answers. Non-statistical questions do not. So we're going to jump into this first little warm-up here, which is determine if your answer would be the same as your classmates. So for question number 1, how many letters in the alphabet? Is that a statistical question or a non-statistical question? That is non-statistical because there are 26 letters in the alphabet. And if you and your classmates know that, everyone's going to give the same answer. So question 2, how many centimeters are in a meter? Is that a statistical question or a non-statistical question? That one also is non-statistical. There are 100 centimeters in a meter. That's the only answer there is. So that one is a non-statistical question. Okay, notice that both of those are number answers. So just because something is a number answer does not mean it is a statistical question. Question 3, how many letters are in your last name? Is that statistical or non-statistical? That one is a statistical question because people will have a variety of different amount of letters in their last name. And question 4, what size shoe do you wear? Is that statistical or non-statistical? That too is statistical because people have different shoe sizes. Okay, so you will be doing a little bit of graphing in your Big Ideas homework. So when you have statistical questions, you will get a variety of answers. Here was a science experiment on house mice. And the teacher asked you, what is the weight of a mouse? And so if you look at that chart there, this chart over here, there are 20 different, oh, is that one of the questions? I hope not. Okay, so 20 different mice were weighed and they all had different weights, and here they are. So that I just answered that for you. Is it a statistical question? Yes, it is, because the mice have different weights. The weights vary. So it is a statistical question. So what you're going to do on some of your homework assignments is you're going to have to graph a group of data. And sometimes you'll be given a group of data on a graph, and you have to come up with a list of numbers that gave you that graph. So I'm going to go through this one in general, and then you're going to have to do it a bit on your own. So the way this works is to display the data on a dot plot. You're going to do a line, a horizontal line, and below the line, you're going to put the numbers that you need that show up on that data. So it looks like our smallest one is what, 18? Any smaller than 18? So I'm seeing 18 all the way up to about 28. Is there 29 there? No. So 18 to 28. So your lines will go right below your line. You have 18, 19, 20, 21. And don't skip any, even if they don't show up. And so you end up with a chart that looks something like this. So it goes 18 all the way up to 28. There's a gap right here because none of the mice weighed 24, 25, or 26 grams. But you still put those on the number line. And then each dot, this is why it's called a dot plot, represents a mouse. So there were 2 mice that weighed 18 grams. There were 3 mice that weighed 19 grams. What was the most common weight of mice? The most common weight was 20 grams. There were more mice that weighed 20 grams than any other weight. And you can see that by the 6 dots. That meant 6 mice were 20 grams. Okay, so usually the question will have to do with which one showed up the most or what can you tell from the information. So here you can see that the typical weight of a mouse was about 20 grams. All right, so when you're doing big ideas, let's say it wants you to graph this on a dot plot, this is what big ideas will give you. They give you the number line and they give you the dots. You have to figure out, okay, well, is there a 16 on this list? There is, there's 1. Is there a set? And so there's 1 dot here at 16. Is there a 17 on this list? No. So this 1 dot at 70, and I grab the little thing and I move it down. So there are no 17s on my dot plot. Are there any 18s? No, there's no 18s, there's no 19s, there's no 20s. So I'm going to drag all these dots down, 18, 19, and 20, because those aren't on this table at all. 21, we got 2 21s. So for 21, I actually drag it up, and now there's 2 dots here at 21. So when you're graphing on big ideas, that's how it works. There's a little slider, draggy thingy. You might have to drag some down to 0. Also, if you accidentally drag one down to 0, you just go down to 0 and you can move it up from there. Okay, so when you graph on big ideas for dot plots, that's how it's done. Okay, moving on. Some of your graphs will also be horizontal graphs. They'll go out this way. So this one's a little tricky because it says you record the high temperature every day while at summer camp in August. Then you create the vertical dot plot. So each dot represents a temperature that day. So how many weeks were you at summer camp? Tricky question. Okay, so hopefully you counted up all these dots because that tells you that there are 28 days here. But it asks for how many weeks, and there's 7 days in a week. So 4 weeks was how long you were at summer camp. Okay, how can you collect this type of data when you're collecting the high temperature every day? Yes, you would use a thermometer. And what would the units be for this right here? It would be Fahrenheit, because if that were Celsius, everyone would die. So you would use a thermometer and measure in degrees Fahrenheit. And then write a statistical question that you can answer using the dot plot and then answer the question. So my question for you is, what is the typical temperature at the camp? So this one actually kind of has 2. So 81 showed up a bit and 86 showed up a bit. You kind of see a cluster here around 86 and a little cluster here around 81. So you could say that it was actually about 81 or 86, about half the time around 81, around half the time around 86. Okay, and now the last little example, and then you're going to be working on these on big ideas. So the dot plot shows the times of 6th grade students in a 100-meter race. So how many students ran the race? Okay, every dot represents a student. So you just count up the number of dots, you'll find out, oops, I gave you all the answers. Well, all right, we'll just fly through the rest of this video then. There are 20 dots. And then how could you collect the data? Well, if you're timing them on a 100-meter race, you would use a stopwatch, and you would normally do it in seconds if it's a 100-meter race. And then write a statistical question you could answer. So you could say, what is the fastest time? You could say, how long does it take a typical student to run 100 meters? Most of your big ideas assignment will ask you about typical values. So you kind of look for clusters, or it'll ask you about gaps. It might say, were there any ranges where nobody fit in there? So nobody ran 13.1 seconds. Most students ran about 13.8. Okay, so that is your introduction to statistics. I've gone on long enough with this video. Your job will be to answer if it's statistical or not statistical. You're going to be making dot plots, and you're also going to be interpreting those dot plots. I'll be around during On Demand if you have any questions, or you can email me or stop by Mrs. Rude in the ASC, and she can help you out. We're going to fly real fast through Chapter 9. We're going to be basically doing it this week and testing on it early next week, and then we're going to be done. Crazy. All right. Good luck. I will see you during our next live session. Ahoy, and whatever pirates say to say goodbye. Arr!